Okay, so today we're going to be talking about exponents, and when talking about exponents, it's important that we understand all of their properties, okay? Because later on we're going to have to solve some equations, and in order to simplify the equations, we have to understand how to, or not how to, but we need to understand the properties of exponents to do so, okay? So the first property that we're going to talk about is the product of powers. Alright, and this is one that we already know, and that's when we multiply two variables, two of the same variable, and they both have exponents. We just add those exponents. So a to the m times a to the n equals a to the m plus n. Okay? So we're going to lift up this first flap, and we're going to write our examples, or we have our examples. So for example, x squared times x cubed equals x to the fifth, because 2 plus 3 is 5. We're multiplying these two, they have the same base, so we can just add the exponents. Yeah, it's fun and easy. So the same thing works with rational exponents, or fractions, as our exponents. So x to the 3 halves times x to the 4 halves, we can just add those two together. They have the same denominator. Okay, so 3 plus 4 is 7. I used to be a hand model. No? Okay, sorry. Alright, so the next one that we're going to talk about is the power of powers. Okay, so if we have an exponent and we take the exponent to a power, so a to the m to the n, we can just multiply the two. So we have a to the m times n. So anytime we take the power of a power, we just multiply the powers, multiply the exponents. So for example, if we have x squared to the third power, that's x to the sixth power. So that's 2 times 3. So 2 times 3 will give us our 6. Same here with the fraction. X to the 1/2 power to the third power. Multiply those two, we get x to 3 over 2. And that's the power of powers. Don't mind the bling. Okay. I know it may blind you. Okay. Just focus right here. Alright. Don't mind it. I know. Swag. Okay, so the next one that we're going to talk about is the power of a product. Okay, so when we multiply two variables and they're both raised to a power, so a times b to the power of n, we can just distribute that n. Okay, so we have a to the n times b to the n. We can distribute because this is multiplication. Alright, if this was addition or subtraction, we can't distribute this n. So since we're multiplying ab to the n, we can rewrite that as a to the n times b to the n. So here are some examples of that. Okay, so here you'll see we distribute the 2 to ab, so we get a squared times b squared. Here we already have an x squared, so when we distribute the 4, we're multiplying these exponents, so we get x squared to the 4th, which is x to the 8th, y cubed to the 4th, which is y to the 12th. And here, we want to take note that we distribute the 3 to all three, so the coefficients and the variables. So you see the 8 here. Well, that 8 comes from the 3 being distributed to the 2. So 2 to the third power is 8. 2 times 2 is 4, times 2 is 8. So that's what happened there. Okay? Does this make sense? Okay. Winners. Okay. No, not west side. This is winners. Okay. Because we're all winners. Okay. So the next thing we need to know, the next property is the quotient of powers. So like the product of powers up here, when we were multiplying two variables that had exponents, two of the same variables that had exponents, we added them. Well, here we're dividing by two of the same variable that have exponents, so we just subtract the exponents. And we subtract the denominator from the numerator. So that's a to the m minus n. That's the quotient of powers. Okay. Yeah, I want to see something funny. Okay. No matter how hard I try, okay, see all my fingers? No matter how hard I try, I can't put them all together. See? As much as I shake and I try, it doesn't work. No, I didn't break it. I think like one of my uncles when I was little said, "Oh, let's do this," when I was a baby. And he just squeezed my fingers and now they're funny looking. Laugh out loud. Lol. Okay, so now the quotient of powers, okay, when we have x to the fifth divided by x to the third, we just subtract them because they're the same variable. So 5 minus 3 is 2, so get x squared. Here we have 3 minus 8, so we get x to the negative 5. And if you guys remember from early in the year, when we have a negative exponent, we can bring the exponent down to the denominator and change it to a positive 5. And we'll talk about that later. Okay? Do you guys remember that? Or why? No? Okay. It's all gravy. Yes. You guys ready? Okay. So that was the quotient of powers. Next one are the power is the power of a quotient. So like when we had the power of powers, when we had the power of a product, when we were multiplying, we could distribute the power. Same thing with division. When we're dividing, we can distribute the power. So we have a divided by b to the m. Well, we can write that as a to the m divided by b to the m. Only time we can distribute an exponent is when we're multiplying or dividing. Okay? So here goes the examples. Did you guys get this right here? Alright. Give you a little more time. Okay. So here we have x over y, x divided by y to the third power. You can just distribute that 3 to top and bottom, the numerator and the denominator. So that's x cubed over y cubed. In this example down here, you'll see that we have a coefficient of 3. So this squared term, this squared exponent needs to go to the 3 and the x. So that becomes 9x squared. And the bottom is z to the 4th. So z to the 4th squared is z to the 8th. We just multiply those. Okay. This right here is a y. Some people thought it was a 7. Some people thought it was a 4. But it's a y. Okay. Is it distracting if I do this? But if they're watching the video right now, they're upset at me. They're like, stop doing this. Okay, I'll stop. Yeah. Okay, so this is the power of a quotient. So last one we're talking about, the last tab will be for notes, but the last one we're talking about are negative exponents. Okay? Negative exponents. I'm going to have to write a little bit to show you, help remind you guys why we can do this. Okay? So, when we have negative exponents, alright, we can write a negative exponent in the denominator and change the sign, okay? So, if I have x squared, that's the same as x times x, right? Right? Okay, so when I have x to the negative 2 power, this negative sign here, that's letting us know that we're going to do the opposite operation. So instead of multiplying by x, we're dividing. So we'll get 1 over x and 1 over x. So we're dividing by x twice. Instead of multiplying by x twice, we're dividing by x twice. Okay? And that's equivalent to 1 over x squared. Because 1 times 1 is 1, and x times x is x squared. So this is why when we have a negative exponent, we can write it in the denominator as a positive exponent. Okay? Does that make sense? Because it's the opposite operation. So instead of multiplying, we're dividing. So here we will have some examples. Okay? So you'll see we have x to the negative 3. We write it as 1 over x to the third. Okay? Here we have, I forgot to show this in an example, but just as if we have a negative exponent in the numerator, when you put it in the denominator, if we have a negative exponent in the denominator, we can put it in the numerator. And it'll change the sign. So it goes both ways. Yes. Okay? So here, in this example, the only part that has a negative exponent is the y. So y to the third is the only thing that gets moved below the denominator. Does that make sense? Same thing goes for the other examples. This here is an 8. This here is an x. No, there's no test on Friday. I believe your test is not until Wednesday. This is hard? Okay. Did you get mad when I do that? Hurry up. If you don't keep up, you'll be left behind. So life lesson. I'm just kidding. Just kidding. Some people might leave you behind in life. Okay. So last one, the last sheet. These are just notes, okay? These are just side notes. So these aren't necessarily properties, these are just things we should know. So anything when we have a rational exponent, okay? The numerator is a power, okay? The denominator is a root. So the best example for this is this one right here. 7 to the 2/3 power, okay? That's 7 squared, and then the cubed root of 7 squared. Yes, right? You don't have to write this, all of this. The most important part is this part right here, the top part, okay? Does this make sense, though, that the top, the numerator is the power and the denominator is the root? So this is like saying 7 squared and then the cubed root of 7 squared. So this is like taking the cubed root of 8 and then taking it to the 4th power. Or taking this 8 to the 4th power and then taking the cubed root. Okay? Because if you... Okay, so if we had... Hold on a second. If we had x squared, right? That 2 is really 2 over 1. Any whole number, it can be written as itself over 1. Okay, so really, this is x squared, and the root is 1, but that doesn't change anything. So here, if we had x to the 1/3, okay, we're not taking it to the power or anything. X to the 1/3 is the same as the cubed root of x. That's all that means. Anytime we have a rational exponent, the denominator is like taking the root. So if we had x to the 1/2, that's the same as the square root of x. If we had x to the 5/4, that's like saying x to the 5th power, and then you're taking the 4th root. Okay? The other thing that's important... Where? Right here? Yes. Right here? And right here. Yeah. Yeah. But the square root is a 2. Okay. Alright, the other important thing to know is that anything to the 0 power is 1. Anything to the 0 power is 1. Okay, we gotta remember that. So 100 to the 0 power, x to the 0 power, y to anything to the 0 power is 1. Would you guys like to see why? Yes. Okay. Yes, and I'll show you why. Okay. Anything to the 0 power is 1. Okay. So if we have x to the 0. Okay, if we have x to the 0. Is that the same? If I say x to the y minus y, is y minus y 0? Yes. So no matter what y is these are equivalent to each other. Okay. Well, this is one of our exponential properties. All right. So we're going to go backwards. If you guys look at your notes that we went over, we can write that as this. Okay. Because when we divide this should be that y is an exponent. Okay. So when we divide two variables and they have this two of the same variables, we can subtract the exponents. That was one of our properties. So we can go from here to here, and then x over y and x over y, that's 1. This is like 5 over 5. You have the same thing over the same thing. So when you divide something by something, and they're the same, we get 1. So that's why x to the 0 is always 1. X to the 0? Yes. I mean, any Yeah, you're right. Anything to the 0 is 1. Anything to the 0 is 1. Okay? Alright, so that's what I want you guys to know. So you want to write down this part here, and then also any number to the 0 is 1. Alright? You guys have a good day. Peace. Winners. Bye.